Welcome to Land Eco Lightning Talks and Thinking Like a Landscape with Dr. Kevin McGarrigle. In this 8-part series on the natural range of variability concept and current departure, I will discuss the origins of the concept, definitions and alternatives, applications, and important considerations in the implementation of the concept. In this talk, part 1 of the series, I will introduce the concept and discuss its origins. Okay, let's get started. You might recall from one of the previous Land Eco Lightning Talks, I discussed a major paradigm shift in ecology from the climax view to the dynamic view of ecosystems. This paradigm shift originated in the 1980s and really came to fruition in the 1990s, and was one of the major impetuses for the emergence of landscape ecology as a discipline. Recall that under the climax view, ecosystems were seen as constantly tending towards a steady, stable, and relatively persistent climax or end point of succession. And disturbance was secondary to this tendency towards this climax condition. And the corollary of this was that ecosystems were generally viewed as relatively distinct and discrete and independent entities that could be studied solely by looking within the boundaries of an ecosystem and to look at the structure and function. But the shift to the dynamic view basically involved recognizing that disturbance and succession processes drive natural variability in ecosystem and landscape structure, composition, and function. And one of the major conclusions from this paradigm shift was that variability was deemed a better descriptor of ecosystem and landscape dynamics than the central tendency or climax condition. This paradigm shift to the dynamic view corresponded with a similar shift in the management of ecosystems and landscapes. And we saw the emergence of ecosystem management, kind of a holistic view and a holistic way of thinking about ecosystems and landscapes. And at the same time, with the emergence of ecosystem management, we saw a shift from a focus on threatened and endangered species or individual focal species to ecosystem integrity. Prior to this emergence of ecosystem management, much of the focus in management was on individual threatened and endangered species. And in some ways, we can think about this as a fine filtered approach to the conservation of resources, where we focused on individual elements such as individual species. But with the emergence of ecosystem management, we saw a shift from focal species or individual ecosystem elements to biodiversity conservation at large and ecosystem integrity. Ecosystem integrity was seen as kind of a coarse filter for addressing the needs of all of the ecosystem elements, including all of the individual species. But ecosystem management required a baseline or reference. And natural variability or natural range of variability kind of emerged as an approach for providing that reference for ecosystem management. Some of the first attempts at natural range of variability implementation involved designed target stand conditions based on historical evidence. Specifically, the attempts involved recreating historical stand structures and selecting an appropriate stand structure based on a single historical snapshot, then designing a silvicultural or prescribed burn treatment, and then implementing those treatments to create a contemporary stand with a structure similar to that single historical condition. This target stand approach, though, encountered many problems. First, it was the wrong scale for effective management because variability occurs at multiple scales, but especially at scales much broader than single stands. It also involved selecting a condition that represented a single snapshot in time, as opposed to representing the variability that would be expected to occur over time at any given location. And it was found to be difficult and inappropriate to treat the entire landscape with one treatment. Fundamentally, the most important limitation of these early attempts is that they did not recognize the inherent variability, which was the basis for the natural range of variability concept. So there were a number of revelations based on these early attempts. Most importantly, that incorporating ecological variability into management is deemed the key to maintaining ecosystem integrity because it ensures optimal biodiversity. It recognizes the critical role of disturbance in regulating ecosystem and landscape dynamics, and it widens the options for management and ultimately helps to maintain ecosystem resilience. That idea is essentially conceptualized in this figure, where any number of ecological attributes of the system, or what we might call state variables, naturally vary over time, as shown by the trajectory in this figure. And using the average simply doesn't characterize and capture that meaningful variability over time. This all led to a seminal publication by Landris et al. In 1999 in Ecological Applications, which was a collection of papers that served as the foundation of the NRV concept. But none of these papers dealt with applications. They were theoretical and conceptual in nature. And of course, many papers have been written since in the past couple decades. And not surprisingly, the concept is still in somewhat of a state of flux. NRV still has many problems in implementation and probably always will. And of course, there are questions today about the viability of this approach with rapid climate change, which we'll address at a later point in this series. The NRV approach, as summarized in this seminal publication, but reinforced over time with subsequent publications, is based on a number of premises or assumptions, if you will. Another way of thinking about this is these premises represent kind of the motivation and the justification for using NRV as an approach. And pulled out here 6 major premises for this NRV approach. The first is that ecosystems are naturally dynamic, and native species have adapted to disturbance-driven fluctuations in their habitats. Therefore, the potential for survival for any given species may diminish if temporal and spatial patterns of species habitats shift outside their natural range of variation. And that's depicted conceptually in the figure shown here. Whereas we depart from that natural range of variability in space and time, the risk of losing genes or species or ecological processes increases. And of course, our uncertainty about that risk increases as well. The second major premise or assumption underlying the NRV concept is that approximating historical conditions provides a coarse filter management strategy that's likely to sustain the viability of diverse species, even those for which we know little about. Similarly, because of limited understanding about ecosystems, approximating past conditions offers one of the best means for predicting and reducing impacts to present-day ecosystems. The third premise or assumption underlying the NRV approach is that managing within the constraints of site variability in history is easier, requires fewer external subsidies, and is much more cost-effective than trying to achieve management goals that are outside the bounds of the system. An example shown here is for beach stabilization on the eastern shore, and a decade or two ago, it was estimated that at least $6 million per mile per decade would be needed to maintain the system in its current state, basically to fight against the natural forces of landform dynamics that is characteristic of barrier island and barrier beach systems. The fourth assumption or premise underlying the NRV concept is that natural variability is a useful reference for evaluating the influence of anthropogenic change in ecological systems, including lakes, commodity production lands, and protected areas such as wilderness. So NRV, if nothing else, gives us a reference for what the state of the system would have been like in the absence of major human modifications. And we can use that as a benchmark, if you will, to see where we are today, where we might be going in the future, or how might our alternative management strategies change the landscape? The fifth premise or assumption underlying NRV is that the analysis of an ecological system at different sites and over long time frames provides the context that is important in understanding the driving variables, the constraints, and the behavior of a system. And such analysis yields essential understanding about the dynamic ecological processes that drive both spatial and temporal variation in ecological systems. So if nothing else, NRV allows us to gain a better understanding of how the system works, how the system behaves, and that understanding then allows us to manage the system in a much more responsible way. The sixth and last premise and assumption underlying NRV is that the spatial and temporal heterogeneity per se is an important component of ecological systems. Reducing that spatial and temporal variability typically results in declining biodiversity, increased vulnerability to insects, pathogens, or other disturbances, and decreased resiliency to subsequent disturbances. And there are numerous case examples where human simplification of the natural world and loss of variability, both in space and time, results in catastrophic changes to the ecosystem and loss of ecosystem function and services. On a really pragmatic standpoint, it's also important to recognize that for some agencies and organizations, they actually have a mandate to use the NRV concept. As an example, the U.S. Department of Agriculture Forest Service has a planning rule, the latest being based on 2012, that basically guides the management of national forest lands. And the planning rule states that planned decisions affecting ecosystem diversity must provide for maintenance or restoration of the characteristics of ecosystem composition and structure within the range of variability that would be expected to occur under natural disturbance regimes of the current climatic period. So this essentially represents a policy mandate the NRV concept be used to guide ecosystem management on national forest system lands. Okay, the major take-home message for today is that natural range of variability is the key to maintaining ecosystem integrity. NRV helps to ensure optimal biodiversity, recognizes the importance of landscape dynamics, widens options for management, helps maintain ecosystem resilience, provides a useful benchmark or reference framework for understanding the system and evaluating human impacts. This is Dr. Kevin McGarrigle signing off from this episode of Land Eco Lightning Talks. I hope this talk has been helpful and hope you join me for my next lightning talk. In the meantime, keep on thinking like a landscape.